So I'll be covering some of my recent PhD research, which is based at Cambridge and funded by the Natural Environment Research Council. So I've been investigating the organisation of Acheulean knapping kits, with interest in trying to understand some of those dynamics of how hammer selection in particular affects final handaxe forms in the shaping process, and how that might materialise archaeologically. In particular, trying to recognise where soft hammer emerges. So the use of antler and bone for late stage handaxe shaping has often been quite load-bearing theory in terms of how we divide up the Acheulean, with the idea that it sort of corresponds with the later period. Um, but yes, that's a sort of big part of my project. But I've been investigating this for a combination of experimental work and now archaeological application. And in doing so, I've been able to explore some broader questions. So I've become interested in this idea of risk tolerance, with different approaches to knapping having different associated risks and rewards that obviously differ by level of experience. And so I'll be going through some of these ideas today. So first of all, I'll just justify why handaxes are so important to study. These represent the earliest tools we have evidence of, which show a sort of clear standardized concept. So as opposed to some simple flakes, there's clearly a design to this, which is shared by multiple members of these groups. Additionally to that, these tools represent the longest technical complex described in human history, so emerging sometime before 1.8 million years ago and persisting for more than 1.5 million years thereafter. So spanning sort of some of the earliest members of our genus, Homo erectus, and persisting until sort of that's contemporary with our own species. And while handaxes are not ubiquitous, they seem to be the central component of industries where these are present in most cases. So most assemblages are predominated by waste flakes as well as the handaxes themselves. And these are often proposed to be sort of the all-purpose knife, um, often associated with butchery, but that might just be a sort of a product of the fact we can actually see faunal remains and study that association more in depth. There's no reason why these weren't used in broader sort of foraging tasks and tool making. And indeed, use-by studies have indicated that there's broader functions to handaxes than butchery. So while there's this continuity of tool form for, you know, more than 1.5 million years, it's often envisaged that there's actually sort of, clear changes over space and time, in particularly the division between the early and later iterations. So the early Acheulean is characterized by these less reduced handaxe forms, which are as a result sort of bulkier and more irregular, compared to the later Acheulean, where you're seeing more intensively shaped tool forms exhibiting greater regularization and often 3D symmetry. Of course, the sort of strict idea of an early and later Acheulean aren't always that well fitting, and that's demonstrated quite nicely in this recent paper by James Clark, showing that across African sites, the refinement or relative thinness improves steadily over time, rather than there being some abrupt shift. Nonetheless, the emergence of the so-called later Acheulean is often important within sort of evolutionary schema. So there's this idea that the the emergence of later Acheulean tool forms corresponds with these evolutionary changes, in particular the emergence of post-erectus hominins with larger brains. So there's a direct association often made here between handaxe form and cognitive evolution. However, we can see actually that there's also more variation in this, and it's not unilinear. So in some regions, you're seeing sort of oscillation in these features. And indeed, when we look to regional scales, we can see that there's more going on here. So that includes this nice study by Anton Müller and colleagues looking at the late Acheulean in the Levant and showing that there's lots of variation between specific sites. And in these instances, differences in handaxe forms are more credibly related to different ecological and cultural settings, not necessarily just cognitive evolution. So moving on to how these nicer, or these more refined, supposedly handaxe forms are shaped. This involves longer reduction schemes, so more intensive flaking, and in particular the implementation of thinning flakes shown in blue here, which kind of remove mid-portion volume in these humps, and also sort of trimming removals, which are important for sort of getting the symmetry and straightening this cutting edge. And these features are often related to different and more complex technological strategies, in particular the use of platform preparation, and marginal percussion with a soft hammer. So we have evidence of soft hammers from 500,000 years ago, but it's inferred to go back up to 1 million years ago, despite the fact that we only really have sort of 4 or 5 Acheulean sites, all of which are in Europe, essentially. So there's a big question mark here. Nonetheless, the expansion of these handaxe reduction chains to have more features and more sort of nested subgoals has been related to the expansion of working memories and potentially of group knowledge. So there's this recent paper by Page and Peru who suggests that these number of actions, or what they call procedural units, begins to exceed what is individually discoverable within a lifetime. And so this for them is evidence of inherited cultural practices and cumulative culture. So obviously very important and is often sort of suggested to be this really sort of inflection point in cultural behaviour. We can think about complexity in terms of the actual number of steps involved, as well as the actual difficulty of implementing those. And so there's been a lot of research looking at skill acquisition in handaxe manufacture, and the largest to date is this one here, led by Pargetta. And this included 26 participants who were guided through 90 hours of practice. And this nicely illustrated that there's a very quick initial uptake of skill. So within a single session, participants could learn to make a handaxe, but actually there's a very rapid plateau. So between sort of 20, 30 hours and up to 90 hours, there was no real distinguishing features of these handaxes. And this falls below the threshold you see in experienced experts. And this is it's been suggested that extending this plateau, there's this sort of this learning curve further. It could take some individuals up to 500 hours to get to this level of expertise, which in other terms, is about 20 minutes a day for 4 years, which as a napper sounds, close to being right. And this is within a context which might be seen as ideal for learning. So these participants are all young adults, and they have had unlimited access to raw material and expert guidance. And of course, they're also doing this in a context where they are just motivated by making an attractive tool, and they haven't got this ecological pressure to make something functional. And I think this is probably one of the problems we have when thinking about experimental data, is that for knapping at least, it's often contextualized within sort of aesthetic features, and particularly looking at novicehood is often considered as apprenticeship. So the main interest is in how people get to this point, and not necessarily what it means to be at this state of expertise. Obviously, if these are not very productive tools, then these 500 hours are very expensive. And this idea of the cost of learning is of big interest to me and a big theme of this presentation. So toolmaking has lots of implicit costs. Materials must be collected, time and energy must be spent, and there's this persistent risk of injury. And we can also think about risk within the actual flaking sequences. So every time you hit the tool, there's a chance that that will improve or worsen its form. If you speak to any knapping expert, they can tell you about hundreds of times they've removed one flake too many and ruined it. So following these sort of assumptions, I have 2 main questions for today. The first being, what are the best strategies for less experienced knappers intending to make functioning tools? Obviously, we know what works best for the experts, but is this an appropriate model for people who are less experienced and their goal is to make something functional? And further to that, how do those short-term strategies shape long-term skill development? So I'll just briefly outline my experiment in this. So I recruited 10 expert and 10 novice knappers. The experts had a large range of experience from 1 year to 50 years of knapping, but all had a proven capacity to make late Acheulean style handaxes. Whereas the novices had between 1 and 20 hours of prior experience, including 1 hour before the experiment where I sat down and guided them through some basic knapping and essentially ensured that they knew basic strategies, but also were doing it safely. So after this introduction, I gave each participant flint flakes and asked them to make 4 handaxes for me, modeling this target form here. And this reduction was broken up into two stages. So there was the roughing out, where they were just asked to impose an initial bifacial edge around the perimeter. And then once they're happy with this, they gave it back to me. And for 10 minutes, I scanned that in using an Artec 3D scanner and then returned that to them where they finished the tool, either using antler, bone, cortical flint, or quartzite, which have variable softness. And so that plays into this other aim of the study to investigate the role of hammer-type on shaping and morphology. And then obviously after this, I scanned the handaxe in again. And so as a result of this, I have a nice record of handaxe forms changing from the initial flake blank to the rough out and then finished form. On top of this, I also have experimental footage from which I extrapolated the sequences of successful flake removals as well as misstrikes where a flake didn't come off. And so this is the novelty of this experiment compared to previous work, is that rather than relying on end products, I have this really nice record of actually how handaxes change for reduction and how um, errors and sort of other knapping gestures change throughout knapping. And so this is just giving you some of the data from the footage. So these are histograms showing the sum of all the flakes and misstrikes across the duration of the knapping tasks, obviously divided by experts and novice groups. And what you can immediately see is that there's differences between these two signatures. So one thing they have in common is that as reduction goes on, the ratio of successful flake removals to misstrikes decreases, which is described here as a flake rate. But you can obviously see that this is much more substantial for the novices. So whereas the experts manage to maintain a flake rate, which is more than 50%, um, but before the end of the rough out stage, most novices begin to deliver more misstrikes than successful flake removals. The other thing worth noting is that there's differences in the total number of flake removals. So on this axis, it's 400, and this axis is 200. And this difference is mainly in the finishing stage. So for the experts, they removed an average of 43 flakes in the rough out stage compared to 33 for novices, whereas in the finishing, they removed a further 94 compared to 36. And just to give you sort of some visual idea of what I'm talking about here, this screen is just showing you a random selection of the roughouts between novices and experts. And you can kind of see actually that between the two groups, there's not very much to pull them apart. I don't think you could really point to one of these and tell me which one is a novice and which one's an expert. However, looking to the finished handaxes, there's a much clearer discrepancy. So obviously the experts are much closer to this model form, and show much more regular forms compared to the novices, where these aren't that different to the previous roughouts. And this corresponds nicely with a principal component analysis. So for those who aren't familiar, PCA essentially simplifies morphometric data, morphological data, into these main axes of variation. So PC1 here is representing an axis from more triangular and thin handaxe forms up to ovular and thick forms, whereas PC2 is mainly characterizing the irregularity. So 0 is, nice and symmetrical on both plan form and profile, and deviation from this is showing, irregularity. And what you can see is that the roughouts for both the experts in blue and novices in purple occupy pretty much the same shape space. And the mean of this, the pluses, are very close together. And so these groups are actually statistically indistinguishable, indicating that the sort of rough out morphology is very consistent across participant conditions. However, looking to the actual handaxes, you can see that there's a much clearer distinction. So the expert handaxes shown here in red have a much sort of tighter ellipsis, characterizing 90% of the handaxes. And you can see that this is close to the model form shown here in orange. The novice handaxes do move closer to the target form than previous roughouts, but you can see this ellipsis is much broader and actually characterizes almost as much variation as the former roughouts and actually extends further on the PC1 axis. Another way we can visualize these changes from the roughouts to finished forms is through linear regression. And so these graphs are characterizing sort of roughouts on the x-axis and handaxes on the y-axis. here by asymmetry and sinuosity. So in reading these, we should bear in mind that anything that comes across plots along this sort of center line here has gone unchanged. Points that fall above this line have actually become worse through the finishing stage, and points that fall below it have improved. And we can also consider the slope of these regressions. So a flat regression indicates that there's no the configuration of the rough out has no real resemblance to the finished form, whereas a meaningful slope indicates that there's a relative relationship there between the two. And so first looking at this graph on the left at asymmetry, sort of, characterized there, you can see that all these points for both experts and novices consistently fall below this line. However, there's a clear difference between the groups. So the finishing stage is more advantageous to the experts compared to the novices. But interestingly, the regressions are very similar, indicating there's a similar proportional change for the rough out and finishing stage. And my interpretation of this is that novices and experts have a similar capacity to impose symmetry. It might just be that the experts are further down here because they have longer reduction sequences. However, when we look to the sinuosity, which is characterizing sort of edge straightness, you can see there's a much clearer discrepancy. And so the regression for the experts is insignificant, indicating there is little or no relationship between the rough out form and the handaxe form. So however irregular the rough out is, they can reconfigure this edge how they want to in the final form. However, for the novices, this line only plots slightly below the sort of zero line and has a similar slope, indicating that the rough out, the finishing stage, only makes minor improvements to the sinuosity, and this is very proportional to the prior state. So there is a very clear persistence of features from the early stages of shaping on the final handaxe form. And because these regressions are so dissimilar, I think this is strong evidence that experts are fundamentally better at managing this, and it's not just a product of longer flaking sequences. And the one characteristic which shows clear divergence between the groups is with the width to thickness, so relative thinness, where you can see that the expert handaxes improve steadily, and then almost in complete mirror, you can see the novices' handaxes become relatively thicker. And this has often been interpreted as a feature of novice knapping, but this is sort of, I think, the most direct evidence we have that this is a clear distinction between levels of expertise. And so this indicates that as novices continue to reduce handaxe forms, at least in this trait, they move further away from the model and they can't manage mid-portion volume in the same way. The other attribute I was interested in analyzing was the edge angle, which I did using this sort of automatic approach developed by Muller and colleagues, where you import a scan into MATLAB, and this will automatically generate an average for the whole tool, particularly works well for bifaces. And you can see the results on the right-hand side, and this shows that for the experts, there's no detectable change between the rough out and handaxe edge angles, whereas for novices, there is a clear jump. This isn't by many degrees, but it is very consistent. So more than 90% of novices show this increase in edge angles through the finishing stage. And my interpretation of this is edge crushing, which I measured manually by comparing crush circumference to hole circumference, which is kind of plotted here, crushing index, just a percentage, which has a very strong correlation with these edge angle measurements. And you can see this example on the right-hand side is a very extreme example where a novice has completely battered the cutting edge. And this is really beyond the point of no return. The edge angle is more than 90 degrees. And actually, just taking flake off that at this point is going to be so hard. And I suspect that this is why we're seeing such a strong correlation between duration into knapping and the flake rate for novices. So it may be that actually, as these errors accumulate, the actual viability of removing a flake decreases. And this accumulation of errors is nicely shown in this other plot, where I'm plotting the crushing index to the observed flake rate. And what you can see is that for the novices, there's a very clear relationship with low flake rates corresponding to high crushing. But interestingly, this relationship is not observed for the experts. So even when there's a relatively uh, low flake rate in the finishing stage, this does not translate to a high crushing rate. And so this indicates that actually there are different consequences and levels of risk by expertise. It seems that when experts make mistakes, these are either less severe and also reversible. And so this nicely chimes with prior observations, including this one here, suggesting that novices do not solve their mistakes, but actually they don't adjust their behaviour and they end up with an accumulation of errors. And so this pulls into a broader question here, is less sometimes more? And the most extreme example of this is the quarter of instances where novices fundamentally broke the handaxe before it was finished. I forgot to note earlier that if a rough out was broken, I gave them another flake blank to start over. But if they broke the handaxe in the finishing stage, I scanned this in, reconjoined, and kind of quite generously pretended that they stopped right before that sort of cataclysmic break. And they were also asked to maintain handaxe dimensions that were more than 10 centimeters. So that's part of the sort of judgment of when it's gone too far. And it's important to try and relate these observations from the experiment with what functional data we have. And the most useful study to this is this one here by my current supervisor, Dr. Alistair Key. So for his PhD, he studied, I think, 500 handaxes and did some experiments seeing how form affected functionality. And surprisingly, there's a broad window of opportunity for different handaxe forms. So it's only really the very extremes where there was a real discrepancy in functionality. So you can see here on PC1, characterizing very bulky handaxes to be sort of hyper-refined forms. There is no observable correlation between these forms and the time taken in cutting tasks. However, in this other study, it's shown that um, a minor blunting of the edge causes severe changes in performance. So in this, flakes were tested with or without a single abrasive stroke against a bit of sandstone. And obviously, when they had been abraded, the cutting force needed in an instron task suddenly went dramatically up. So marrying these two studies together, it indicates that actually the integrity of the cutting edge is more important than the gross morphology. And relating that now to my results, it suggests that actually knappers should prioritize this part of it rather than this. And I suggest that the novices generally tended to overshape the handaxes, and actually the rough out configuration was closer to their functional optimum than what they gave me at the end. The other thing I want to briefly sort of bring up is that we often think about functionality in terms of efficiency, when I think there are actually broader things to consider. In particular, when we're sort of crushing these handaxe edges, we're creating all these partially released flakes, which are quite hard to flick off from the tool, but could come off spontaneously during use. And so, if you've got all these sort of micro flakes in your food, this has a severe risk of internal damage. And I have heard horror stories of exactly this happening. So I think this is another aspect which might drive conservative error avoidance strategies. And so trying to relate these observations to the archaeological records, I think this idea of the early Acheulean being a crude industry is, perhaps giving them not enough credit. Actually, this might represent a pragmatic approach to tool making. So they may not be a limitation in their cultural imagination of what the tool form could be, but actually them recognizing that the payoff from taking more flakes off and making it a more attractive shape might not actually be an advantage to them. And I try to sort of test this idea a bit further by comparing the novice roughouts to earlier Acheulean assemblages, including one of these sites openly available from Ubedja. So this is 1.2 million years old, and you can see superficially there's a resemblance here to some examples. And if we're looking at the actual sort of some of the key metrics, key morphometrics, you can see that these, there's a lot of overlap here, very similar metrics come out. And so this comes on to another question of why take the risk? And really, the advantage to risk taking is that you're constantly operating in what Vygotsky would call your zone of proximal development, essentially expanding your knowledge of mapping scenarios. And in a sense, the more you take the risks, the less risky they are in future. Now, why exactly these hyper-refined Acheulean handaxes are an advantage to individuals? I think we need to, that's still a bit an open question, I think. But certainly there's an advantage to being able to tailor your tool form to how you exactly want it, whether that's for social or functional advantages. I think there's also a possibility that these broad stroke functional analyses, where you have to control lots of variables, they may miss some of these sort of more discrete form function relationships. So that there may be more important dynamics going on there we just don't have evidence for yet. And I also want to mention that this propensity for risk taking, it may be cognitive, it may be sort of your ability to prioritize future payoffs, which could be linked to theory of mind and mental time travel, as well as potentially your tolerance of frustration. But also this could relate to broader group dynamics. So in particular, if groups are smaller and they have shorter lifespans, the density of experts is going to be reduced, which obviously impairs your sort of model for what your future skills could be. And also, if you're ecologically less stable, then you may have less time to actually practice. So if you're, at a butchery site and you're worried about confrontational scavengers, you really just need to make a tool. You don't have time to faff around and, do your best work every time. And I think it's interesting to relate some of these ideas to our closest living ancestors. So when we're looking at tool use in chimpanzees, they show much more conservative behaviors. So once they master a strategy which has this calorific promise, they're very reluctant to explore other avenues where this may be more opaque. And this is even in scenarios where it's been demonstrated time and time and again that there's a more productive way to do this. And obviously, the chimpanzees are often used as a sort of conservative model for what early hominins might be doing. Obviously, if we're applying chimpanzees to, you know, early Pleistocene behavior in hominins, then this, should adjust how we think about technology and in particular stasis. So there's the idea that the early Acheulean represents, quite sort of, static technological strategies. Maybe there's something there. And obviously, we're now looking to modern humans. There's a very important role of deliberate practice, which is seen to be unique in our, in humans. And so, unlike other species, we will actively practice behaviors which have payoffs way into the future. And the most obvious and relevant case studies to this are the Langda axe makers in Iran, where it's seen that young boys will accompany experts to the quarry and practice on softer stones, which actually aren't so productive for actually tools. And it's said that for the first few years, nothing they make will come back with them. And so this is entirely manufactured within the context of learning. So obviously, I'm very interested in when something like this might emerge evolutionary, which is a very difficult question to address. Now, obviously there's a huge amount of caveats to this because it's making a lot of assumptions about individuals, which, is so ephemeral when we're dealing with rocks and bones. Nonetheless, I think Boxgrove is one of these extraordinary sites where we have some interesting observations we can kind of recall here, which brings some sort of archaeological theory into this. So for those who don't know, Boxgrove is a site located in southern Britain. It's around 500,000 years old, and it has some of the best handaxes as it's considered from the Acheulean world. And I just want to bring up some work by Dietz Stout and colleagues who looked at platform preparation in the handaxe manufacturing flakes. So this is shown on the right here, where you can see that there's sort of this marginal sort of flaking on the platforms, which indicates that they were actively preparing the angles and surfaces of these striking platforms in the opposite direction to where these final thinning flakes were taken off. And where this technique is applied to the flakes at Boxgrove, this corresponds to smaller platforms and thinner profiles, which is ideal for handaxe thinning. And this is also the relationship observed when looking at expert experimental samples. However, this group also looked at novice and inexperienced knappers trying to do this technique, and basically they showed that when these individuals attempt to do this, they actually get a worse result. So they get thicker flakes with large platform areas. So this is the complete opposite of what you want for handaxe thinning. And in this context, the novices were said to be archaeologists with intermittent experience with knapping over several years. So this is people who have a detailed understanding of what platform preparation is, and still they fail. And so this is a nice indication that actually there's a threshold here, and before that, attempting to prepare platforms is a disadvantage. And so this is again a nice evidence for active practice. And the other extraordinary thing about Botsgrove is that it has the oldest and largest collection of Acheulean soft hammers, including 3 examples from Antler. And I'll just briefly touch upon some of my data from the hammers used, ordered here by hardness. And so this plot is basically showing the rankings by the groups. So every individual at the end of the experiment was asked to rank their favorite tools, with their favorite getting 4 points and the least favorite getting 1 point. And you can see that there's a clear spike here for the experts around Antler, but for novices, this corresponds essentially with hammer hardness. And they did not get on nearly as well with the soft hammers. And so this is another indication that actually there's no initial payoff to using these tools, and actually to realize the advantages of soft hammers takes actively sort of pushing against the grain. And this is even in the context where I actively show them and describe why soft hammers are often used. And particularly when we're looking into Botsgrove hammers where these must have been seasonally collected in advance of the knapping itself, and lengthy preparation to actually segment the beams and stuff. So this is not a spontaneous, this isn't just messing around. This is something that's sort of actively been prepared for in advance of knapping, showing a lot of investment for something which takes a lot of skill to do right. And so the implementation of platform preparation and soft hammer use seems to manifest in its sort of best forms as some of the best handaxes we're seeing from this period anywhere in the world. Not just in terms of the refinement and sort of quality of the flaking, but also in more than 80% of examples, we're seeing these tranche tip sharpening. And so this is sort of shown here in this recent paper led by Kerry Shipton, where these arrows are indicating these tranche flake removals. Essentially, this technique is when you carefully prepare a platform at the very tip of it and send these flakes, which will overcut the bifacial edge, leaving this razor sharp sort of flake-like edge. Now, while this clearly has an advantage functionally, this is a very high-risk strategy. So if you get something wrong in the preparation of the striking platforms or the actual blow itself, you can end up doing sort of some really severe damage to the most important functional component of the handaxe. So obviously the tip is where the loading force is highest and the cutting stress potential is too. So this can be a severe detriment to the tool if done wrong. The other aspect of this is that because it's such a volatile and unpredictable type of sort of tool alteration, it should really manifest as greater variation in plan forms. When actually this PCA analysis is showing that if one tranche flake removal is taken off or two on both sides, this actually corresponds to a more standardized subset. And so this may either represent that only the very best knappers are trying this, or perhaps that actually this group where there's no tranche flaking, it may be that they are trying it, but they're failing so badly it's not even recognized. And in this paper, they suggest that actually there's a performative aspect to this, suggesting that particularly with the double tranche technology, this has a very high risk of breakage for marginal functional gains. I think we need to actually do some experiments here and actually test how much this facilitates cutting tasks. However, this idea of exaggerated risk-taking, I think is quite interesting. I have another slide on this, looking at other possible scenarios where this, extravagant risk-taking might manifest, particularly in terms of some giant handaxes, although I've cut it out because of time, but you can ask me about that at the end if you want to. I think equally important to these sort of superlative handaxe forms of Botsgrove, it's worth thinking about the so-called non-orthodox handaxes, such as the example that's on Sketchfab, where you can see it's very small, it's relatively thick, it's asymmetric, both in plan form to some degree, but also in profile in particular, and has all this crashing along the edge. And to me, this sort of manifests a lot of the key traits we're seeing in the over-determined or over-shaped novice handaxes. So to me, this is possibly a kid practicing. Certainly by the point this edge is getting to this, battered up, it's not going to function very well. I don't want to put too much weight on individual tools because it puts on so many assumptions, but I think these signatures are out there and it's worth looking into the broader patterns of um, handaxe morphologies and with traits that might correspond to expertise. And I just wanted to finish up on this idea that risk tolerance might be important in how we understand broader patterns in technological change. So I think it's no coincidence that the emergence of these more refined handaxe forms, which require more risk, sees a diversification and regionalization of handaxe forms, as well as the emergence of new tool forms altogether. So it suggested that the vowel emerges out of handaxe technology in the later Acheulean, and also we're seeing the origins of hafting, and that includes this biface from TD10 of Atapuerca, where it's suggested to have projectile damage on the tip, so may represent a hafted spearhead. Obviously, this sort of theme of risk and reward is not the be all and end all, but I think it's an interesting thread to follow and may be important in how we model cultural development, as well as intergroup variation potentially. So I will wrap up there, and I just want to say thank you to my supervisor, Dr. Alistair Key, Natural Environment Research Council, the Cambridge Archaeological Unit who hosted these experiments, and of course all the participants, as well as everyone for listening today. Also, the first publication that's coming out of this research is out now, and there's a link to this here if you're interested in looking into that further. Thank you.
Thank you, Finn. That was a really interesting talk. As usual, if anyone has any questions, please use the raised hand function or just put it in the chat for me and I'll call on you. I've got one for you, Finn. Does the archaeological record at all seem to reflect that there are more or less teaching of knappers happening in areas where there's more raw material availability?
I mean, I've not been looking into this. So this is, I think I that needs to be done for sure. And
Yeah,
I do wonder. I think, if I'm not mistaken, there was a suggestion at Beecher's Pit that there might have been learning in that context where it's a relaxed, campsite supposedly, because the handaxes there are quite variable. And I think that that should be done at Box Grove. I mean, there may be that the further distance you are from the cliff where flint is eroding, the higher the more refined handaxes may look.
yeah,
And yeah, comparing sort of kill sites or butchery sites to areas where actually there might be opportunity for practice would be really interesting to do, but
yeah.
nothing I've done yet.
Be a nice thing to see. A very human connection to make.
Mm.
Got a comment from Matt Grove, says, thanks, really nice analysis.
Oh, thank you.
And we'll just hang around for any more questions. Oh, here we go. Joel Darcy says, hi, Finn, thank you very much. Just wondering, do you think risk tolerance acceptance may have linked to signaling culture where handaxes that exhibit risks suggest positive aspects of the makers?
I mean, there's no reason why not. I mean, it's so hard to. I'm quite avoidant of getting sort of too deep into social theory because it's just there's so many untestable things. But these ideas are definitely worth thinking about. There has been a suggestion that people making nicer hand axes is exampling, their proficiency. And I mean, if you look at nappers across the world, they are, they're show-offs. I think it's a natural thing for people to do to some extent. Yeah, yeah, why not?
Yeah. And we've got John Gall that's got his hand up. I think you might be on mute there, John. Not getting you still.
You hear me
Oh,
now?
yes.
Yes.
Yes, sorry. No, I really enjoyed that. Thanks. Been very, really very interesting. Now, one thing you didn't mention that I'm sure you've thought about is the actual starting blank and the effect that has. So I guess in theory, if you have a large flake Acheulean, you could be very good at striking the blank, and then not all that good at trimming it, or almost vice versa. Have you any thoughts on that?
Yeah, no, I absolutely. And I do wonder whether we seem to see the start of this emphasis on large plates with minimal shaping before we see these sort of highly shaped handaxes. And I wonder whether actually that is to do with that, where there's a prioritization of predetermination through sort of specialized flake release, as opposed to these sort of other tasks, other strategies where actually it revolves around more and more flake removals. So I think that's definitely something to think about. And I think there was a recent study based on some images in South Africa suggesting that again, there's an emphasis of large flakes into Acheulean in order to sort of get around the challenges of the raw material, which wasn't so susceptible to nice sort of façonnage shaping. So certainly, yeah.
Yeah, yeah. Well, the great thing about these things is you set people thinking, and I think in the large flake Acheulean, the thickness of the blank affects the weight, and then yeah, a thicker blank is going to be harder to give sharp edges. So there are trade-offs there, and I think we haven't explored them very much yet. Yeah.
Absolutely. Yeah. Yeah. No, thank you.
Thanks, John. And we've got a thank you from Lydia in the chat. And it looks like we've got a question from Carlos.
Yes, hi Finn. Lovely to see
Hi.
you again, and congrats on your research. I just wanted to add something regarding the comment from Professor John Gollett because I'm studying, as you know, the Acheulean in the Iberian Peninsula, where there is a large flake Acheulean component, very well demonstrated. And I was thinking the same. That is, in my case studies, I see there is a clear correlation between the degree of suitability of the blank and the intensity of the secondary reshaping of the blank, especially when these handaxes are made on large flake blanks. That is the norm. You clearly see that in most cases they are only shaped on one side, usually the dorsal face, or they are like partial handaxes. They don't really have an extensive bifacial shaping because the flake itself was already suitable for the intended tool. And even when these handaxes are on pebbles, I am seeing clearly that is like a selection of tabular or rectangular pebbles in which you already add a flat surface that on one side it served as the striking platform to perform the extractions that configure the tool on the other side. And on the other end, you didn't have to reduce or like flatten that side. So yeah, in the case of Debian and Acheulean, you clearly see a correlation between the suitability of the blank and the intensity of shaping. But in this case, we are also talking in 99% of the cases of handaxes that are made on quartzite. So the impact of raw material can also have should also be considered in this discussion. It was just to add on the previous comment this information.
Yeah,
Congrats.
certainly a need to try and correspond risk and reward in its relative context because, yeah, I think material has, it's not the be all and end all of everything, but it certainly, I think, structures a lot of habits. I'm also really interested in some images you can see where you've got classic large flake Acheulean, but also at the same time you have these sort of highly sort of thinned hand axes through shaping. Like I think Gesheban Yakov, uh, I think some sort of East African sites as well. You're seeing sort of both these two techniques together, and is that representing, different strategies by individuals within the group, or do people generally have a mastery of both strategies? Or is it sort of yeah? There's so many dynamics here we have to investigate further, I think.
Yeah, thank you.
Thank you.
Fabulous. Thank you, Carlos. If we've no further questions from anybody, last chance, we'll think about wrapping up. We've got more thank yous from Joel and John in the chat. Yeah, it looks like that's about it. So thank you very much, Finn, for agreeing to come on and giving us this talk. It's been delightful. And thank
Thanks
you
for having
everyone
me.
for joining. And hope you enjoy the rest of your week.
Great.
Bye
Cheers.
bye.
Bye.